Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Quart University of Science and Technology. Today we will take lecture number 9 of the subject of Introduction to Computing, in which we are going to discuss the network topology and network hardware. Dear students, network topology represents the architecture of the networks, that how different nodes in the networks are arranged and they communicate between different other devices. And network hardware contains important hardwares which are used to install in the configuration of the network. These are the discussion topics here with us. It contains the topics of topology. First we will define the term topology. Then we have types of topologies in the networks. We have star topology, bus topology, ring topology and mesh topology. These are multiple topologies are the structure of the networks. Then we have the network media. Network media contains wireless based media and wireless media. Wired based means that we will install the wire as a network media, and in the wireless media we will install the antenna as a wireless media. And also we have the networks hardwares. So here we will we will understand some important hardwares that are used to install them or configure the networks. What is the network topology? Network topology represents the layout of the wireless or wires networks. Basically, in the network topology, most of the networks are arranged in the wires and they are equipped with each other. So these are representing the logical layout of the wires and equipments used to connect the network. Now we have multiple choice of the topologies, but these affects upon certain criteria. First one is network performance. If we require high performance, then we will utilize one sort of the network topologies. For example, star topology has a greater network performance. And if we require network size, means that if you are working over a big network, so then we will connect the mesh networks topology. Also depend on network collision detection. Network collision detection means that when the data collides with each other, then the data will lost. For example, in mesh networks, the data may collide with each other and then the packets may be lost. Several different types of topologies are here with us. Now we are going to discuss each and every one in the detail with the relevant diagrammatical representation. The first topology is called the bus topology. Student, here by bus we means a link or a channels which connects the different nodes or computers of the networks in a line. Also called the linear bus. As its name indicates, that represents the linear bus. You can see that these three computers are connected with each other in a linear. Similarly, these two are connected with each other also in a linear line. And they are connected with a common bus here. That bus is a communication channel. And terminator is used at the ends of the wires. For example, here we have also terminator, here we have also terminator, and the terminators helps us to terminate the line. For example, if this computer is sending data to this computer, then the data will send here, and when it will see the terminator, it will come back and then the data will be sent here. So terminator terminates the bus. The advantage of this topology is too easy to be set up. So we can easily install or configure these networks. And smaller amount of wire is used, means that if we see the cost of the wires, so here you can see that only man wire and few sub wires are used here. So that eliminates the cost of the wires. But it has disadvantages as well. So the first disadvantage is it is slow. Slow means that first if the node want to communicate with this node, then the packet will be transferred here and then the packet will check whether the destination is this computer. So the packet address contains the address of the computer. So then the packet will come back or bounce back by this node, and then the packet will be transferred here. So first the packet will check this computer, then this computer, and then this computer. So that's why it is very slow, and also easy to crash. Crash means that the packets will be lost easy, and hence networks will be crashed. For example, if this computer is sending multiple packets, so then there will be collision among the packets and the packets may be crashed with each other. Another important technology is called the star topology. This topology is in the form of the star, where different computer or nodes or the other hardwares are connected through the hub like stars to other computers. So packet sends to the hub. For example, first this computer want to communicate with this. First the packet will be sent here, then the packet will be sent here according to the destination. So hub sends packets to the destination and the packet contains the data. It has the advantages. First advantage is that it is quite easy to be set up. Means that we can easily configure or establish this network, because we need just one central hub or switch and all the computers are connected with each other through this hub or switch. So also one cable cannot crash networks, means that if this cable has crashed but still other cables will work. But as compared to the other topology that we have discussed here, that is a bus topology, if this cable crashes, then this computer cannot connect with this. Similarly, if central bus crash, then all the computer will be disconnected. So there are multiple cables, so that's why it cannot be crashed easily. But it has also disadvantages that one hub crashing downs entire the networks. If this central hub or router is crashed, then it will down all the networks. So everyone will not be able to communicate if this central hub or router will be crashed. Also, it requires a lot of cables as compared to the previous linear topology, because you can see that everyone is connected with this hub or switch. So that's why it requires a lot of wiring, and hence it is very costly network. But it is most common types of topologies, and it is mostly used for small networks. For larger networks, this topologies cannot work. Another examples are the types of topology is the ring topology. As its name indicates, it is in the form of a circular ring. But you can see that each and every computer is connected with other computer through one wire in the circular fashion. So this is the ring networks, or ring topology. Here token is used to transmit data from one node to another node, and if for example this node is transmitting data to this node, so this node will wait either from this side or from this side, depends on the shorter path. If this path is shorter, then this will be followed, otherwise this path will be followed. Sometimes the data is sent to both paths, but the one which becomes first will be the destination packets. So node must wait for the token to be sent. But it has advantages. It is time to send data is known. For example, if you are sending data here, and now in the few seconds the data will be appeared here, so we can calculate the time of sending or the time of communication. And no data collision may occur. For example, if there is only one packet is sending, then the packet will go either from this line or from this cable. So if it is going from this cable to this computer, then there will be no collision because multiple packets cannot be sent here. Also, it has disadvantages. It is quite slow. Slow means there is no alternative path from this computer to this. There are two alternatives, but no direct path here. So that's why it is slow, and lots of cables is required to create this network topologies. We require two extra cables as compared to the bus topology, which requires only one cable. It will be quite less costly because it requires then only one cable. But in In ring topology, you requires more than two cables or two cables here. Another type of topology is called mesh topology. Here, all the computers connected together. And internet is the example of the mesh network. As its name indicates, each computer have multiple cables to connect to its other different computers in the network. So lots of cables is required here, and it is also very hard to set up this network. That's why it is very costly network. But it has the advantage. Data will always be delivered. Means that the sender will always deliver the data until and unless if the data is lost. If the data is received, then the sender will stop the data sending. So it has also the disadvantage, we required lots of cables. You can see that each and every computer is connected to other computers through the wires. So that's why we requires a lot of cables. And also it is quite hard to set. And sometimes we don't know that which computer is connected and which are not connected. So we have to keep a complete record of each and every computer that it should be connected to its peers. So that's why this computer network is very hard to set up. So we have different media that is used to connect the computer. As in the different topologies, you have seen the different lines among different computers. And these computers connect a network. So these lines are in fact the media. Media represents different cables. Sometimes wireless media is better, and mostly it is better in fact, because the wireless media requires no cabling, just you required the infrared signals. The infrared signal is transmitted from a satellite to the base station, and then base station transmit that satellite to the required node. So that's why here wireless media is used. Now what is the media? Basically media represents different lines that connects different nodes, and they may be physical or logical. Now also if we connect the media or we install the media, it depends on our choice. Sometimes better media is available, sometimes bad quality media is also available in the market. So the choice impacts on the number one speed, number two security, and number three size. Always we required all these three characteristics, that is the speed, which means that we required high speed networks so that efficient data should be transferred. Now also we require the security. Different website has its own security mechanism, but it depends also on the media as well. Some media is quite easy to be hacked. For example, if we want to hack the wireless media, it is very easy, but we cannot hack the wired media, and it's very much hard to identify the wires, where that wires go. For example, sometimes the wires are spread over in ocean or on the sea. So under the sea, we cannot detect the wires. So here the security depends on the media as well. Also the size. For example, size of the networks depends also. For example, if we want to connect larger networks, for example, WAN networks, that is wide area networks, then we will require the wireless media. For example, if we want to connect the Quad University of Science and Technology with the other university of the United States, then we will use the wireless media. But if you want to connect two different departments of the Quad University, then we will require the wired media. For example, if the that is the network department want to connect with the admin department, then better choice is to utilize the wire media. But if you want to connect the network department with the other university network requirement, for example with the Peshawar University, then we will require the wireless media. So that's why it depends on the size of the networks here. Now here we will mention some important types of media that is used. These are real media that is used in the networking. First one is called the twisted pair cable. Twisted pair means that multiple pairs are twisted with each other here. So, for example, here you can see that two pairs. Here are also two other pairs. For example, this is one pair and this is another pair. You can also see the difference of the colors here. So this is the twisted pair cabling, and this cabling is suitable for the LAN cable, means to connect to computer over a short distance. It is called Cat5 or 100 base T cable. That is the name of this cable. And four copper cables twisted. You can see that there are four copper cables. They are twisted with each other. And speed is in fact range from 1 megabits per second to 1000 megabits per second. So this is the speed. For example, it depends on the wire. Sometimes it is 1 megabit, sometimes it is 1000 megabits per second. Now, it depends on the quality here. Here we have two different versions. Cat5 are 100 megabits per second in twisted pair cable. These are mostly used here. Other types of wire-based media is called coaxial cable. Coaxial cable represents a different than the twisted pairs. It is more higher than the quality of the twisted pair, and it is similar to the TV wire. In our homes, we can see this wire mostly when we want to connect our television set with outsider voice or IP provider. So then we use this cable here. That is called coaxial cable. Now one wire runs through the cable. So just one wire is required, and you can take connection from multiple wires so many times. So this will act as like the linear topology, where it is also called the bus topology. So one wire runs throughout our home or throughout our department or in our office. So it is shielded from the interference. You can see that this is shielded outside insulation. Insulation is in fact a harder coat here, which in fact protects it from any sort of the damage. And it's also have another copper mesh. Copper mesh is here, but actually the data is sent in here in this copper wire. Another central, and this one is the plastic insulation. And also this one is also the plastic, and this one is also internal plastic, and between these two plastic there is the copper mesh here, which protects or make it hard. So this is the copper wire which transfer data from one computer to another, and speed up to 100 megabits per second. And it is also nearly absolute. It means that it is nearly best one. It is not the best, but it is near to the best one. So its speed is 100 megabits per second. Another types of wire-based media is the fiber optics cable. Fiber optics cable is much efficient than the previous cables because it uses the fiber and also it uses the light, in fact light medium to travel. It is data is transmitted with the light pulses and glass strands instead of the cable. You can see there are the glass strands here. Glass strands are used to transmit the light from one computer to another, and the data is stored in the form of the light. But it is very secure, and also it has the disadvantage that it is quite hard to work with. And its speed is up to 100 gigabits per second. It is very fast. And almost it is the best one to be utilized in the LANs or in the wire-based computer networks. We use the fiber optics cables. Another media is called wireless media. Wireless media, as its name indicates, this media do not utilize any sort of the wires, but it is wireless. And the data is transmitted through the air in the form of the radio wave. Sometimes infrared waves are also used, but mostly in the radio wave, and that radio wave is generated by the satellites. And satellites send that radio wave to the base station, and base station then send the radio to another base station. The base station is connected with the computer. So here data is transmitted through the air, and lens are used as a radio waves. Once use microwave signal, that is the wide area networks also use the microwave signal. That's called the microwave signals. And it is quite easy to be set up because requires in antennas to transmit the signals from one destination to another, but that antenna uses satellites to transmit data from one computer to another. But it is quite difficult to secure. It is quite everyone can access these signals everywhere as compared to the wire media networks because it's available everywhere. So your computer will detect the radio waves or microwaves, and you can easily have these waves so that you may be connected with the networks. That's why hacker mostly uses wireless media hacking techniques to hack the network. Now we will investigate different sort of the network hardwares which requires networking. And with these hardwares we connect one computer to another computer. So these hardwares are the endpoints of the wires or wireless. First one is called the network interface card. This is also called network adapter. It connects nodes to the media. Here you can see this is the port which can be connected to another network interface card. In fact, this network interface card converts the signal into a suitable stacks of the bits, and that bit is understandable to our browser. So it connects node to the media, and in unique machine access code, that is MAC code, is required. Everyone has the unique code that is called MAC code. It is a hardware code which represents the destination computer. Another example of another network hardware is called hubs. It is a center of a star networks because it transmits data to another computers, and multiple computers can be used to connect with this, and it transmits data to multiple computers over a star network. All nodes receive transmitted packets, but it is very slow and insecure. It can easily be accessed. So, and also it is quite slow. Another hardware is the switches. Basically, switches is a replacement of hubs. The switch transfer data to the multiple computers, as like the switch, like electrical switches, where you can use different ports. For example, like battery port, you want to connect your switch with that particular ports, and then the battery is on, and it in fact works. So only intended node receive the transmissions, and it is also a very fast and secure as compared to the hub here. So that is quite easily installed, can be installed very easily, and it is very secure, but it's also very fast. Another network hardware is called the bridge. Exactly like when we connect two cities among each other, we use the bridge. The bridge connects two or more than two big areas. So it connects two or more LANs together. Packets sent to remote LAN across, and other packets do not cross. So means that another packets, if one packet is sent, then the another packets will wait until it uses the bridge, and then the another packet will be transferred. So the segments and networks on the MAC address is used here. So here the MAC address of the bridge is utilized here, that which we have to send the data to which LAN. Now here is the diagrammatical representation of the bridge. This is the bridge here, and the bridge connects two different servers, and then server transfer data to this switch here, and the switch transfer data to multiple PCs or computers. Here this server transfer data and receive data from any node or the client. From here, then the data is transferred to the server, and server transfer data to the bridge, and the bridge transfer data to another server, and then another server transfer this data to the hub or switch here, and then hub or switch will send data to the PC, multiple PC. Every bridge or here the server has the IP address with the port number. So IP address with the port number is mentioned with the different packets, and when that packet is sent from there, then through this switch, then the data is sent to the particular server, and then the data to the particular servers through the bridge here, and then the data is sent to there to multiple PC. So this is the example of the bridge here. Another hardware which is very much important is called router. As its name indicates, a router is responsible for routing. It is exactly like the roads or the streets, and these roads or streets are used to send the required data from one computer to another computer. So router connects two or more LANs together and packets sent to remote LAN cross. If you are using multiple LANs, then it is used to send the packets from one LAN to another LAN, and cross LANs may be also utilized. Network is segmented by IP address. Every network has an IP address, and then this router will decide that from which packet we have to send the data. It connects internal networks to the internet. One network, for example, KUST, is connected through the overall internet, where we can view or send the data from our university networks to the global networks here. Now, it requires configuration before installation. Configuration means that how many IP addresses will we want to locate here. We can use different classes of the IP addresses, as there may be class A, B, C, or any other class of IP address. Now, this device is in fact used to route the data, and it sends data to the shortest routes. That's why this requires a careful configuration. Another network hardware is the gateway. Gateway connects two dissimilar networks. Means that if there are two dissimilar networks, one is a wired network, another one is a wireless network. So these two are different networks. So gateway is used to connect different networks. For example, connect coaxial cables to the twisted pair cable, because they are two different cables. So that's why this hardware, which is called the gateway, connects two different media. And most gateways contain in other devices. Most gateways are in fact contains in other hardware devices as well, because this is the built-in gateways here contained in other devices. This is the example of the gateway. You can see that this is the gateway. Some connects in fact another gateways here. Then this gateway connects the antennas, and also this gateway connects the desktop system to be utilized. Also this gateway connects another PDS and another laptops and PDS also. So here we have multiple gateways here. So different gateways connects different hardwares, and it depends on their usage as well. Similarly, the gateways can also connect the OTT, that is over-the-top media servers. Over-the-top media server is special types of server that is usually reside over the media here. This is the, for example, coaxial media here. This is the network cabling specification. How we will design, designs this particular cables, and what will be our choice here. The cabling specification depends on the bandwidth measures cable speeds. So that means the speed of the cable, which is also called the bandwidth, should be in fact used as a basic criteria of selecting the cables, and typically measured in megabits per seconds. In the next slide, we will show you how the megabits is in fact represented by the cables. Also, maximum cable length also defines the specification of the cable. If we require the maximum cables, for example, if we want to connect two cities which are in the residing over two different contents, then we will use the wireless cables or wireless media. If we are connecting two different departments located in the same university, then we will use the fiber optics cables. Now, connector describes the type of plug as well. Depends on the connector. We have also certain plugs here. The plugs are the endpoint of the cables. You can see these are multiple cables. First one is called the Ethernet cable. It is very popular cable technology. When we want to connect with the LAN through the wire, we will use the Ethernet cable. So Ethernet cable has, for example, 10 base T, 10 base 2 or 10 base 5 different version of the Ethernet cables. and maximum bandwidth is 10 megabits per second, while the maximum distance it covers is 100 to 500 meters. So that's just covers two different buildings only that are located very near to each other. Another is the fast Ethernet cable. In the fast Ethernet cable, it is quite faster than the other cables. It is the new version of the Ethernet cables, and its bandwidth is 100 megabits per second. And it uses category 5 or greater cable. This is category 5 cables, or it is greater. Sometimes also called 100 base T cables. So this is another name for the this cable, that is 100 base T cable. It requires a switch at the end of this cable. So endpoint requires the switch here to be connected with the switch here. Now another examples of the cable is gigabit Ethernet cable. It has high bandwidth version of the Ethernet, and it is from 1 to 100 GBs per second, that is gigabit per second. So that's one is very fast, and high amount of data can be transferred over the gigabit Ethernet cable. And it has category 5 or fiber optics cable. Mostly the fiber optics is very much renowned cable. It uses the fiber optics cables as a gigabit Ethernet. Also, it is used for video applications because video requires high bandwidth. So that's why we require gigabit Ethernet or the fiber optics cables. You can see that this is fast Ethernet and this is gigabit Ethernet. Speed is 10 by 100, 10 or 100 megahertz, from 10 to 100 megahertz, but its speed is from 10 to 1000 megabits per second. It is category 5 cable. It is also category 5E, also category 6A. So these are two versions of the gigabit Ethernet cables. These are the diagrammatical representation of this cable. You can see there is the category 6A cable, which is gigabit Ethernet cable. Another one is called token ring cable. As its name indicates, it's used shielded twisted pair cabling and bandwidth between 10 and 25 megabits per second. It uses a multiple access unit (MAU). Multiple access units mean that multiple computers can be accessed through this cable, and popular in manufacturing and finance. So mostly this cable is developed and manufactured because it has the highly cell advantage. So that's why this cable is very much renowned. Well, students, this is the end of the lectures. If you want to study more about these topics, in fact, these are very concise topics and very much in the easy terms. So you can read this book for details. That Introduction to Computers by Peter Norton. So you should download this book and you should read it. And if you have still any question, you can send your questions at the email. My email is m.kadim@kust.edu.pk. I will wait for your question and will respond as soon as I get them. Thank you very much.